So let's look at an application and think about what is a better representation, the mean or the median. In this example, we have 6 home prices sold by a realtor in Albany in the past month. I've listed those home prices in order, low to high, and what I'd like to do is find the mean and the median and then discuss which one would actually make more sense to describe these 6 houses. So for the mean, I would go ahead and take all of those home prices, add them up, and divide by 6. When I add those home prices up, 120, 180, 190, 210, 280,000, and then 2,100,000, I would get $3,080,000. And then we're going to divide that by how many there are, which is 6. So the mean we'll need to round off because it won't come out evenly will be 513,333. You'll see the 0.33333 going out. So we need to round this off. Now, I suspect that these home prices were already rounded because they all end with 4 zeros. And since they all end with 4 zeros, it's probably the case that the realtor, when she reported this, just kind of rounded off into the nearest thousands what each of these sale prices were. So we could technically round this off at 513,000, but we'll just keep it out to the nearest dollar to make it easy. The other thing to calculate is the median. The median is the middle home price. Now, we don't have a single middle home price here. We actually have 2 that are in the center that are near each other. So if you don't have a single home price that's in the middle, what you're going to do is take the average of the 2 that are in the middle. So what's halfway between 190 and 210,000 would be 200,000. So we have a median home price of 200,000 and a mean home price of 513,000. So let's talk about which of those would be a better measure of these 6 data points, these 6 home prices that are sold, these 6 homes. If you think about it, this 513 is unlike anything we see. It's much higher than the first 6 and much lower than the last one. So it's kind of that mean is kind of out there kind of on its own. What's a little bit more representative of most of the data is the median, because the median is close to these first 6. You know, it's kind of around what is happening with those, I should say not 6, first 5 out of the 6 data points. The only one that it's not like is this really high home price, which was 2 million mark, around 2,100,000. This one is very unusual. In fact, we call very unusual data points like this that are very different from the others. Sometimes we'll refer to those as outliers. In this case, our outlier is very high. And so the median is at 200,000 is much more representative of the first 5, which is the majority of the data set, than it is of the high value. Whereas the mean is not representative really of either in some ways. It's kind of in the middle. What has happened with the mean is that the outlier has pulled it up toward that high value. It does this because the mean is calculated by looking at all of the data values altogether. And because this home price of 2 million is actually worth 10 of something that is more typical, it's worth 10 $200,000 homes, it is going to have more weight and influence the mean more than everything else will combined. And so it actually pulls it up and it kind of gives you a skewed image of what's typical of these these homes that this realtor has sold. So the median is often a better measure of what's happening on average in a data set when you have an outlier that might skew things. So if you look at a newspapers, especially with homes, and also the newspaper will do this with salaries, will often go ahead and give the median as an average instead of the mean because it's trying to avoid outliers skewing the data in terms of the mean calculation. So median home price is a little bit better here for a representation of the data values in general. All right, so let's talk a little bit about these outliers. Remember, outliers are going to be unusual data values, specifically unusual high or low data values in a data set. And that outlier can affect the mean by pulling it up or down toward it. Now, we talked about shapes of data in the last section. And I used bar graphs, but here I'm just using the overall shape in a kind of a curve-like setting. Symmetrical data is when you have a high point in the middle, and then the graph kind of has the same shape on either side. When you have that high point in the middle and the same shape on either side, you will always have the mean and the median lining up at that same place. They will be the same. And actually, the mode is at the high point, so the mode is actually there as well. So the mean, median, and the mode will all be in the same location in a symmetrical data set. When you have a skewed data set, whether it's skewed to the left or skewed to the right, and remember skewed refers to where the tail goes off to, and the tail is where you're going to have outliers, what's going to happen is that you're going to have the mean getting pulled down toward the outliers. So I have these three lines here, and I want to talk about these three lines. The one at the peak would be the mode. The mode is always going to be at the peak. So you'd have the mode here, kind of at the peak. And then the mean is going to get pulled toward the outliers. So the mean is the one that is further toward the tail. And then the median is going to be between them, because the median is going to be in the middle of the data. And the middle of the data, because you have this tail going off to one side, is going to be slightly to the left of where the mode was, because the middle is now going to be slightly shifted toward the tail, but not as extremely as the mean will be. The mean is always going to be shifted more toward the tail, toward those outliers, than the median is. So you have the mode at the high point, the median pulled a little bit toward the tail, and then the mean pulled a lot toward the tail. So if we look at right skewed data, where the tail is on the right, you have outliers on the right. Let's kind of repeat this process. The mode is at that peak. The median is going to be a little bit toward the outliers in the tail, and then the mean is the one that really gets pulled toward the outliers. Once again, the median kind of moves toward the tail just based on how much data is located on either side. If you were to actually look at the area here and the area on this side, and this is what the median refers to, you've actually got the same number of data points on the two sides. But that same number isn't going to be at the peak anymore, which is why the median gets shifted slightly. It's because that tail has got more data in it. And so the median gets shifted just slightly. But it's the mean that gets shifted the most. It's the mean that gets shifted the most. So you will always, in skewed data, have the mean heading toward the outliers. One more application. And thinking about which average is better. A company that makes cleaning products has created a new disinfectant to kill bacteria. It runs tests on its effectiveness on 10 surfaces. The percentage of bacteria eliminated on those surfaces was recorded as 67%, 99%, 91%, 87%, 99%, 70%, 99%, 69%, 92%, and 61%. Find the mean, median, and mode. So go ahead and pause the video and find those, and then we'll look at them together. All right, so I went ahead and ordered the data, and I left off the percent just for space, 61, 67, 69, all the way up to those 3 99s. And you must list each 99 out separately. Then I calculated the mean by adding them all up and divided by 10. There were 10 surfaces here. One thing to double check is make sure you really have added all 10 of them together, and then make sure you're dividing by 10. One thing that can happen when people are calculating means is they accidentally leave one value off, or they type it into their calculator wrong. So if you didn't get 83.4%, double check that you entered things incorrectly and that you entered all of them in. The median would be the middle of the data set. So in a data set of 10, that would be between the 10th and the 6th, or sorry, fifth and the sixth in a data set of 10. So in the middle, we would have 87 and 91. Halfway between 87 and 91 is that 89. You can do that either just by looking at it or by adding those two middle values together and dividing by 2. And then the mode is what you see most frequently, and 99 is the most frequent percentage here, so that becomes the mode. So those are our 3 measures. If you're representing the company, so the company that's created this new disinfectant, what average would you want to use to market this product? So if we think about that, for them, they want to show that this product gets rid of bacteria. So of these 3 values, the 99% is actually going to be a better marketing plea. And so they would probably use that 99%, and they wouldn't be lying. What they could say is they could say, the product eliminates 99% of bacteria most frequently. You might say in more of our studies, or in most of our studies, it eliminates 99% of the bacteria. So you're using an average, but you're still being honest. So there's nothing wrong with saying this. In more of our studies and most of our studies, it eliminated 99% of the bacteria. So that certainly is the case here. However, if you're representing a hospital, the average you might care about might be different. You wouldn't want to know what is the most frequent result. You would want to know about what happens in general over all cases, because you care about eliminating bacteria everywhere. And so you'd probably care about looking at that mean. So depending on who you are, the owner of the company looking at the mode or the hospital looking at the mean, you kind of need to think about how different averages might be better in different situations. So the mode is certainly applicable. Another example where the mode might be used would be if someone is looking at stocking shelves, or like for instance with a particular, if you're selling clothing, or for instance selling shoes, maybe t-shirts, what you would want to do is look at the mode. What do you sell the most of in terms of restocking your shelves? You wouldn't want to take a look at the average size that you sell. If you're selling sizes like from 4 to 16, you would want to look at what you sell the most frequently. So the mode, which is the most frequent value, would be what you'd care about in those marketing situations as well.